So this is designed to sort of give everyone in this community an update on what's going on in the low-level parts of this. Obviously, RDMA is how most of the communication networks end up being exposed into UCX, whether it's Mellanox or Huawei or even EFA now from Amazon is coming up through that framework in the kernel. So things that happen here tend to trickle their way into the UCX world. So the good news is that everything is still going pretty strong in the open source community. We still have a healthy number of contributors and patch flow, and lines changed, which means people are working on things. As I made this sort of summary, I reflected that a lot of the work here is actually fixing bugs. So you'll find that newer versions of the kernel and newer distributions have fewer obscure bugs, particularly bugs in corner cases that might not be hit commonly. So if you're having weird problems, upgrade is possibly a good solution. So a few of the more interesting items. We did a lot of work on ODP. So ODP is a unique Mellanox feature called on-demand paging. It's kind of like shared virtual addressing that's become popular to talk about lately. And this little adjustment lets you declare that you are only going to use 2 meg huge pages and get a performance win from this inside the NIC hardware. I think this was something like 10% under certain workloads would benefit from having the large page size. We have PCI relaxed ordering. I think I talked about this last year. Alex was asking about this. This came up earlier in the week, the Git inspection API. So on Rocky and InfiniBand, you have a Git table, and the Gits have various properties that are difficult to extract. Currently, you can't access some of them. So this is things like GID type, the netdev that owns the GID, things of that nature. So now you can access all of that from libib verbs. There's an API to return information about a single GID, and there's another one to give you the whole GID table. This is intended to allow applications to correctly select their GIDs instead of just hardwiring 0. We're seeing that there's probably going to be a direction to eliminate Rocky v1, at least in some configurations, maybe a lot of configurations. And that's where it becomes important that applications select their GIDs properly, not just hardwire 0. Because if you hardwire 0, who knows what GID you'll get in Rocky v2 land. The entropy bits is another interesting evolution. We've seen an increase in the use of Rocky in high bisection bandwidth Ethernet networks. And in those kind of networks, you have a multipath that's based on hashing the packet headers, like the IPv4 headers and the UDP headers. And current Rocky hardware tends to only select a single multipath, or doesn't really give enough control over the multipath if you're talking between the same 2 hosts. So you can now specify the flow label. You can specify a random value in the flow label, and it flows through the RDMA APIs and generates an appropriate entropy. The multipath selection is called entropy in Ethernet land, and the appropriate entropy will be put in the packet headers. For IPv4, this will effectively modify the UDP source port as a source of randomization, and this will let you influence the multipath going through. There's some very, very low level APIs and some adjustments that were made. They're kind of similar related to lag. So we can have some control over the lag physical port that a QP is bound to, instead of being trapped on that decision when the QP is created, which is the way it is now. And it's just general more conversion to the ioctal format, which is interesting, but not totally relevant. The kernel's learned to do trace points. So if people are debugging the CM flow, the kernel trace points are actually really good for this. I'm not a trace point wizard, so I can't really give you a great example here, but they have logging and lots of details, and they run at high performance. So you'll be able to see all of the details about the CM messages. You can extract them. You can run BPF programs in the kernel to filter them in the kernel. So you can really dig in really deeply and try and identify interesting bugs there. There's a lot of information out on the internet about how to use trace points in conjunction with BPF and all kinds of other interesting things that you can do Hopefully this will make the CM more transparent. HFI implemented accelerated IP over IP, which means pretty much, I think, all of the InfiniBand transports now implement accelerated IP over IP. This is a version of IP over IP where we just get rid of verbs. I heard Alex mention in an earlier talk that abstraction layers are bad, and this is very much aligned with that philosophy. The verbs abstraction layer between the hardware and the network stack simply got in the way, so we get rid of it, and the network stack gives a packet, and the driver directly places that SKB into its transmit queue without any fuss or translating between different abstraction layers. We finally also deleted FMR support. FMR support is something that is from the two Mellanox drivers ago. So this would be MTHCA driver and other hardware from that era. So kind of mid 2000s. It's early predecessor to what we now call FRWR, Fast Registration Work Request. And it's just horrible. It was horrible. It was full of bugs, and it caused all the ULPs to have multiple paths, which became full of bugs. So the whole thing's just gone. If you're using, if you're really using this old hardware, you don't get to enjoy this feature anymore. This one I think has some relevance for UCX, maybe quite a lot. So I know that there are a number of MPI users that want to do fork while they're running their MPI application. Maybe it's for something very simple, just fork out some kind of helper. They don't actually expect fork to share address spaces. It's probably mostly fork and exec. But if you do that today, while you're using RDMA, you end up with data corruption on the memory that's currently under DMA. This is because the kernel wasn't really aware of the DMA, and when the fork does what's called copy on write, it shares the physical pages, and when it's time for those physical pages to be uncopied, the kernel would make a random choice which of the processes would receive the physical page that's still under DMA. So you could end up with a situation where the parent process is busy doing DMA, it forks, and the fork steals the physical pages that are under DMA, and then the parent is left with copies and can't see the DMA anymore. To counteract that, forever, libIBverbs has had something called IBV fork init, which does a lot of overhead when we create MRs and any other DMA-able object to mark it with something called madvice don't fork. And if you mark the memory with madvice don't fork, it means that the child after fork doesn't get that memory at all. So it solves the problem that the copy on write creates, but it creates a new problem where the memory isn't visible to the child. So if you actually did need that memory because it was in your heap, for instance, your application will now crash. It turned out that in 5.10, Linus had proposed a patch that made the fork behavior go from somewhat likely to 100% likely, and it broke a whole bunch of stuff that wasn't properly calling IBV fork init, and Mellanox objected. We objected from the RDMA side as well. The result of that long discussion was that Linus agreed that the correct thing to do is something called copy on fork. So if a memory page is under active DMA, then fork will copy it, and the child will get a copy immediately. So your fork becomes more expensive, but you completely avoid all of the data corruption. And since the page is still copied, you also avoid the other problem of having the page not mapped into the child. So this is a comprehensive solution. It means that we can remove all of the overhead from fork init and just make it a no-op. But to date, I haven't heard anyone confirm that this is actually working as advertised on the sticker. So I'd really be happy if the people who care about fork init would run some tests on the 5.11 pre-release kernel and confirm that this is all good. And then we'll plumb something in behind the scenes so that if you do happen to call IBV fork init, it just does nothing if the kernel is new enough to supply this optimization.
Jason, would it copy the pages immediately during the fork or on demand?
Immediately during the fork.
So if we have like 300 gigabytes of pages allocated on the RDMA application, which are all registered, it means they would be copied.
It does. If you're doing workloads like that, you really need to have the user mark them as
Sounds
don't fork.
something like pretty much broken to me, because if we have like a huge application which occupies most of the machine memory, but we just fork a small process which does fork and exit, means it wouldn't work.
Right. That's right. That's the semantic the Linux community has decided on for lots of complicated technical reasons. If applications
somehow,
intend to mix fork and memory pinning, they need to use Madvice don't fork. And we have hidden this inside verbs, which I think was a mistake. The applications should take that 300 gigabyte of memory that they know they don't care about in fork, and they should mark it themselves with Madvice don't fork.
so it means it would happen only for pages which are not marked by Madvice?
Yes. Madvice don't fork still works as advertised.
Okay.
I have a question about kernel related part if you're already on RDMA core. Is there any update on DAX support with verbs?
No, there's been no progress on that. You can use DAX with verbs if you use ODP.
It's what we did. We actually built an entire project on top of this, and it worked well. We didn't step on any problems. But you know, ODP, it's kind of unique features that available only with one vendor. And,
Yeah, well, ODP is becoming more important. The talk that was on Monday about the DMA buff GPU patches, they also rely on ODP. It's more or less the position of the kernel community that you have to have something like ODP to access these sorts of memory management features. And I don't really see that shifting. So my advice to the community, particularly the hardware community, is more people need to implement ODP. Or one of the variations. The new Intel and ARM CPUs will have a variation of ODP that relies on PASID and SVA techniques and ATS PRI and things of that nature, which should be a relatively easy implementation for any hardware NIC.
yeah, there's. I don't argue. It would be nice to have all NICs with ODP. The truth is, there's very few, exactly one. So,
yeah.
I support the message. Probably, guys, you have to communicate it loud and clear to other vendors.
I hope people are paying attention.
Not sure about this, but okay, thank you.
I'm not sure. ODP is a very difficult feature from hardware, but I'm hopeful the PASID PRI ATS acronym jumble will make this much more common. So I've been hoping that for
DAX and with memory registration is not going to happen altogether. So it's kind of because now they try to solve it and it didn't go anywhere.
Yeah. Intel and Dan Williams' team put in a pretty solid effort. It didn't really budge. I think the direction will probably end up is that it will just, it's already blocked, but I think we're going to end up blocking even more. Like today, you can make a memory registration against the file backed VMA, but it actually causes the kernel to crash in some side cases. So I suspect that will end up getting blocked as well. I don't know exactly. But.
Thanks.
All right. I guess I should also mention that we've done a lot of work improving ODP performance in general. So ODP has now been moved to use something called HMM, which was designed for GPU page table sharing and SVA techniques, which really matched ODP quite well. So this improves the performance of page misses, and it also avoids page misses in a lot of cases. We can preload the NIC page tables with the CPU page tables without having to cause CPU page faults to happen now, kind of a read without modify of the page tables. So when you create an ODP, it starts up at the NIC with all of the current state of the CPU preloaded already now, basically for free. So if you've already touched the pages the moment you create the ODP, the performance is identical to a normal MR, and it creates faster.
Another question, do you guys require ATS for ODP?
No, none of our ODP implementations use ATS.
Do you know if there is any other implementation using or planning to use ATS?
I don't know of any. I would anticipate that's the logical thing to do. I've heard.
There's a couple of papers kind of showing that ATS does not work well.
Yeah, that's what I was about to say. I've heard that ATS and PRI don't actually work very well. That's probably a different conversation.
Okay.
And that that they don't work well is why none of our implementations at Mellanox use ATS PRI for ODP, because it performs very poorly. In a lot of regards, like it can't even do huge pages. So the 10% optimization I talked about on the first slide is lost immediately just by switching to ATS.
Yeah, okay, thank you.
All right. This is some stuff now, kind of a grab bag of things in RDMA core. So there's been this long-standing difficulty with the RDMA CM where if you hot plug or unplug or even just kind of reload an RDMA device, RDMA CM loses track of what's happened in the system and stops working correctly. So it's now learned how to automatically recover from that. So you can reliably use RDMA CM in the face of hot device plug unplug and have no worries. This is a hidden feature. It just works. It's just fixed. You don't have to do anything in your application. We've added some more fine tuning to let the user control how memory is allocated for CQ rings. This is useful for some of the more esoteric verbs users, like putting a CQ ring, say, on GPU memory or some other thing of that nature. This IBTA has like this new mini extension for the CM called ECE that is designed to let the NICs exchange a little bit of private data between themselves. And it's intended to let the NICs negotiate these non-standard features which have crept into InfiniBand's ecosystem. So adaptive routing, for instance, is a very well talked about feature in Mellanox's InfiniBand implementation. And ECE allows this to be automatically and transparently enabled for applications. So applications do not need to be aware about this extension. If they are working on an adaptive routing fabric, then it just magically gets turned on. And there's a few other little details, little sort of micro features like this that are connected to this feature. And everybody gets to do query device extended now, all of the providers, which is sort of one of the long-standing obnoxious things in verbs, is that too many of the verbs only work in certain cases. So we're slowly trying to move to a world where more of the verbs work everywhere, even if they don't really do any much more than the basic versions. This was a big feature, and I believe UCX or things in UCX's orbit were one of the major reasons for doing it. It's the concept of allowing two processes to work on the same verbs environments, particularly the same verbs PD. So this is particularly relevant if you want to share MR objects or you want to do certain things with Q pairs. You need to be in the same PD. So we now have this framework inside RDMA core with a little bit of support from the kernel where you can transfer the verbs FD, the context FD it's called in the verbs API, to another process in the usual ways. And then you call a new API, the import device, and it gives you a new local IBV context, except that context is the same as the one that was in the originating process. So it has access to all the same PDs and MRs and all the other objects. Then you can create a kind of a proxy for a PD or an MR in your local process and then use the other verbs APIs exactly as you would be able to had you created them yourself. It doesn't work for anything stateful like QP. We don't have any way to share QP ring buffers or CQ ring buffers or do the locking that would be implied. That's maybe not a insurmountable problem.
Can you hack it with DevX, like allocating share the QP buffer and so on?
Yeah, DevXDV certainly could do it. You can create a UMEM on shared memory. You can implement a locking scheme for for manipulating the work entries, or the entries in the queue, and put that in shared memory too, and deal with it that way. You can even do that with the normal verbs using the parent domain stuff to specify where the ring allocation goes. The challenge that's come is that nobody's been able to define a use case where this is actually useful. If you want to do it for some kind of resiliency, you have to consider that the other process could die at any moment, including while it's doing manipulations on the QP, while it's inside its locked region. How do you break that lock and recover to a coherent state is extremely complicated. Nobody's really defined something useful there. There may be maybe.
What is the use case if you cannot share QPs or CQs?
You can share the MR is one of the most important use cases. So if you have a very complicated or very big MR, you can split to another process, and that other process can work on the MR as well. You can also link, it's kind of a weird thing to do, but you could link a QP to a CQ in a different process, use device memory across the two processes. There is still a pretty wide area that's useful here.
Okay. I think there's one pending question from Yossi on chat. Does it mean the CSFS is removed? I'm not sure if
regarding the query stuff.
The SysFS will always remain for legacy compatibility, but the verbs library doesn't use it anymore. So this has been another challenge, is to get verbs to run inside of a container. A lot of people are starting to do HPC work inside of containers, and things get a little weird with SysFS because SysFS isn't namespaced very well in Linux. So we've moved to using netlink for a lot of the things that used to be in SysFS, and netlink is properly namespaced and properly works with containers. So the GID table and the Peaky table were the last two SysFS users in verbs, and now that they're taken out by this new API,
so
verbs
today
never uses
SysFS for other bunch of stuff which are not currently exported through verbs API. Actually, quite a lot. For example, checking the normal locality of each device, checking the PCI link width and speed, and I think there are a few more things. So, also checking the number of ports on a bonding device.
So the bonding one is something that maybe we should think about putting into verbs more natively. But the other stuff, anything to do with hardware locality, NUMA locality, like that's what SysFS is really good at. That's what it's for. I think you need to keep using it.
Okay.
It's a little bit challenging to reliably use SysFS with verbs since we added device renaming. So there's all kinds of sketchy things that are possible when the devices can be renamed, which changes the SysFS path from underneath your feet. But that's more of a theoretical issue than a practical issue, and UCX is probably fine to keep using SysFS for hardware location information. It might make some sense to have verbs export the hardware device path instead of going from the RDMA device and trying to get to the hardware path. That would at least isolate you from the renaming race, and may be an easier interface to the existing libraries for hardware and NUMA locality. We can talk about that if you think there's something there.
Okay, thanks.
So everything is going quite good on the distro side. All the RDMA stuff is flowing into distros at a healthy cadence. Red Hat in particular has been quite aggressive to take new updated kernel components and user components. So if you use a modern distro, you actually get a pretty good experience without add-on packages and things like MoFed. been one of my pet peeves that we haven't been able to do LTO. So that actually got fixed very recently. GCC learned how to do LTO for our kind of library, and now you can do link time profiling and all that micro optimization for cache locality and branch prediction and things that link time optimization allows for. I don't know if that's really important for a user like UCX, which has got its own data plane, which is where most of that optimization would be relevant, but there may still be some merit to manage cache locality and things. I think we solved the SPAC problem with a no man page install option. We talked about this last year, at least in the UCX conference. And, you know, Azure Pipelines has worked out quite well. That was something from 2 years ago. We all agreed to pursue using Cloud CI, both UCX and RDMA CORE sharing the same Microsoft tenant in Azure, which underpins the resources that make this possible. I think I didn't see a topic about it from the UCX perspective this year, but I gather it's still doing quite well. We've got more hardware available in the CI. One of the things I'm keep meaning to look at is if we can use the stuff that was built up for UCX and run maybe hardware-based tests now that we have tests available through that that mechanism. But that's maybe for next year. Which I guess is a nice segue into the test suite. So we actually have a test suite now for RDMA Core and Verbs, which is the first time really ever that there's been a public test suite that anyone can run. It doesn't cover a huge amount, but it's growing every year. It covers a lot of the basic functionality, enough that the people running the test suite on all of the hardware, like
You're
some of the
welcome to
distributions.
take UCX for a test suite. Some
Sorry?
stable version. You can take UCX as a test suite, some stable version.
Yeah.
From my experience, it's beating hell out of RDMA Core if you run UCX unit test.
Well, some of the things the tests are looking at are kind of esoteric stuff, like if I call query device, do I get the right stuff out of it? Does query device extended do the things it's supposed to do? Right? UCX tests a certain swath of it, and it's very hard on the data path. But it doesn't get in all these weird little corners. So I think there's merit for both of them. Certainly, I think anyone making RDMA hardware would be well advised to run UCX as part of their compliance program or their test program. This is kind of a supplement. I would view it more as a kind of a sanity test. I've seen some interest, or maybe even a lot of interest from the distributions. When the distribution builds its distribution, they can run this fairly small test and know, at least at a first order, that they've built RDMA Core correctly, that they've built a kernel properly, that the two pieces are not having any egregious version mismatches and things like that.
We have one pending question from Gal. I can read it out if.
Sure.
Any plans to support non-loopback PyVerbs test for traffic tests?
That's maybe more of an Edward question. I've had the vision that PyVerbs is something you can just run. A lot of the other testing that's been in this area has been very complicated, right? You need to set up two machines, you need to link them together, you need to get all your IP addresses right, you need to use a command line argument that's like this long and hope for the best. And PyVerbs is, at least my vision is the exact opposite of that. You run PyVerbs, there are no command line arguments. It's supposed to work all the time. And that's why it's able to rely on loopback. I would love to have a multi-node test suite that kind of followed that same ideal, where it was much more self-configuring. I don't know if it should be integrated into the current test suite or be a second kind of parallel test suite, but I think it's a really great idea to follow. We have the perf test project also alongside RDMA Core in the GitHub, which is kind of a test suite, but not. It can be used as a test suite, but again, it's kind of horrible. it also depends what you intend to accomplish with multi-node testing. Most of the testing I see people doing when they move to multi-node starts to become performance and less about conformance. But if you think there's conformance issues that are interesting on multi-node, and it certainly would be interesting to do multi-vendor interop with a multi-node test suite focused on conformance, not performance. That was something I think the IBTA and the OFA investigated a long, long time ago. I don't ever know what became of that effort, but it's probably out there someplace.
I just wanted to weigh in on the PyVerbs thing. This is John Howard, because as a GPU-centric person, I was not very good with InfiniBand, so I set up a 2-node system and ran some of those other things, and it was a huge amount of work to get it up and running and to keep it running. And then I moved home to the home office and had just one card and set up this loopback thing, and the PyVerbs just has been a godsend. It's just amazing, the fact that I can get this quick and easy thing that even when I do a git pull, it still works.
Yes.
And yeah, wow, that's fantastic. And so as a kernel developer type of thing where, okay, I've made some changes to the kernel, maybe I touched something InfiniBand uses, I can run this thing and it's pretty good at, failing or not failing, depending on whether I screwed things up. So I didn't realize what Jason said, which was the design purpose, but that design purpose is really valuable. So just wanted to weigh in on, here's a layman user, this is good.
Yeah, I've also struggled with the other tools too. It's quite often, we have people that are in our QA team here at Mellanox, or NBU, I suppose. It's very experienced with these special tools, and they come up with literally command lines this long, and they say, okay, this was the command line and this happened. And I try to run it on my system and it says, you fool, what are you doing? You're not a QA person, go away. So it's kind of frustrating sometimes. But the simplicity was intended to make people able to use it. All right, let's see, what is the next slide? We're reaching the end here. So we didn't have a lot of kind of new driver specific features that I thought were notable. Mellanox has a bunch of stuff that's really focused on DPDK as a user of RDMA, and QLogic implemented XRC support, which is nice to see that XRC still has some life to it. I think it's, I don't know, 15 years old or something at this point, but people are still finding value there. So I guess that's the end. I think there's probably still a few more minutes. Pasha, or am I done?
Let me look at the schedule. Meanwhile, we can open the floor for questions. Yeah, we have time until 11:45.
All right. Well, maybe I'll just
another 9 minutes. So, any questions? Any more questions for Jason about RDMA Core?
All right. Well, maybe I'll just have a little segue here. I don't usually talk about Mellanox OFED, but since there has been some major changes, and I think it's relevant to probably this audience, it's maybe worth highlighting it if people haven't noticed. So Mellanox OFED now has two branches. We have the 5.1 series and what we call a long-term support branch on the 4.9 series. And the interesting distinction here is that the 5.1 series jettisons all of the, or substantially all of the stuff that didn't make it into distributions. So if you run Mellanox OFED 5.1 or 5.2, it's extremely similar to what's inside like a Red Hat 8. And we're really encouraging people to think about just using what comes with the distribution instead of putting Mellanox OFED on things. There's still a lot of use cases, a couple of use cases mostly to do with GPUs where you do need Mellanox OFED, but for non-GPU scenarios on modern ConnectX cards, it's not nearly as necessary. I view this as, I think it will turn into a great benefit for the whole ecosystem, because managing Mellanox OFIT installs is a bit challenging, and being able to get it from your distribution and just, boot up the system right away and just start working is kind of the holy grail here that I think a lot of us have been pushing for, well, since OpenIB was founded, 15, 16 years ago.
Yeah, I can comment from ARM side that we see people mostly using inbox drivers, whatever come with distribution, for a simple reason that a lot of new SOCs and cores are coming out, and it will require, most likely will require very latest kernel version. And the same actually goes for compiler like GCC. And to get all of this, you have to go, which is pretty much Fedora or latest Ubuntu, one of these, and Moffat is typically does not support like most recent version or upstream. So we use vanilla kernels and like Fedora, with latest kernels most of the time for everything. So it's really happy to see that we have better experience actually with kernel upstream and inbox than with Moffat.
Yes, we definitely heard that from a segment of the market customer base. So that's my spiel on that. I guess if there's no other questions, can go to the next.
Jason, one. So, what are some other features which are, main in Moffat compared to the inbox?
For something like UCX, HPC sort of community, I don't think there are any, just the GPU integration. If you look beyond that to the Ethernet community, the sort of NFV community, there's a few more things. And something like a Red Hat isn't as closely aligned with the upstream NetDev as you might want if you're doing work in that space.
For GPU, is there any other direction other than the DMA buff that presented on the Monday, or what are the plans for upstreams there?
Well, the DMA buff looks like a pretty good next step. I would like to still see the GPU integrated with HMM. That's been the vision for a couple of years now. It's been a difficult path to get all those pieces sorted out, and we're kind of at the last step of needing a GPU driver to expose the GPU memory through the HMM paradigm. And we don't have that. We haven't been able to get any of the GPU vendors to kind of play ball in that area. They might change their tune when they start to do benchmarks on HPC systems and kind of realize that maybe the DMA buff approach is not going to scale or is a performance drag. I'm not really sure what will happen there. Maybe it's the best thing. I don't know. But even the HMM approach will still require ODP-like hardware. There's just no way to escape that with GPU integration. The integration we have today, it really only works with, I think, CUDA malloc memory or something. It doesn't work for all of the GPU memory types, and that's only going to get worse as they add more kinds of memory types to the driver and the programming model.
I see. Thanks.
Any more questions for Jason? We have 3 more minutes before next talk.
3 more minutes. Did we get all the things in the chat?
Yeah, you answered everything. So I don't think there's anything else pending. Thank you very much, Jason, for presenting very useful updates. Really appreciate it.